Today is January 18th, and this is the medium daily integral for today. So please try it out for yourself, and now we'll start. So what we're going to do is we're going to use integration by parts. So let's u equal x, and let sine of x, ln of cosine x be our dv. Oops, I wrote it dx. This is dv. So we now have du is going to be 1, which that just leaves us with a dx. And v, well, for v we'll have to do some integration. We'll take the integral of sine x ln of cosine of x dx. So we'll let t equal cosine of x, dt is equal to negative sine x dx. So this gives us negative ln of t dt. You can check this out for yourself. However, this integral will evaluate to t minus t ln of t. So this gives us cosine of x minus cosine of x ln cosine of x. So we now have v is equal to cosine x minus cosine of x ln cosine of x. So now this integral right here will become uv. So we have x cosine of x minus cosine of x ln cosine of x from 0 to pi over 2 minus the integral of v du. Well, here's our v. Alright, du, well, our du is just dx. So we are really just going to take our v, it's cosine of x minus cosine x ln cosine of x dx from 0 to pi over 2. So now let's continue here. We notice that x cosine of x, well, what happens at pi over 2, that x cosine x becomes 0. And when we go at 0, well, x cosine of x is again 0. So we'll get negative cosine of x ln cosine of x evaluated from 0 to pi over 2. And now this right here, right, is going to be a little bit more interesting. What happens at 0? Well, we'll have ln of 1 times negative 1. That becomes 0. Okay. However, at pi over 2, it goes to, well, cosine of 0. Well, that's negative infinity. So I have negative cosine of x times ln of infinity. Well, that doesn't make a lot of sense. So what we'll do is we'll take the limit as x approaches pi over 2, negative cosine of x ln cosine of x. And here there isn't much more we can do. We could take, we are just going to have to really leave this like this for now. So instead we'll look at this integral. Since this limit right now is divergence, we're going to hope another divergent term in this integral right here, right, will cancel out with this term. So let's see. We have negative the integral from 0 to pi over 2 of cosine of x dx plus the integral from 0 to pi over 2 cosine of x ln of cosine x dx. This integral right here, well, this is just 1. So you can check it for yourself. The integral of cosine of x, that's sine of x. So we'll get sine of pi over 2 minus sine of 0. That's just going to give us 1. So we are actually just going to have negative the limit as x approaches pi over 2 cosine of x ln cosine of x, right? This whole thing here minus 1 plus the integral from 0 to pi over 2 cosine of x ln cosine of x dx. So now let's look at this integral right here. We're going to do integration by parts again. Let u equal ln of cosine of x. Let dv equal cosine of x. So we have du, well, that's, what's the derivative of cosine of x? Well, that's negative sine of x. So that's negative sine of x or cosine of x gives negative tangent of x. v, that is going to leave us with sine of x. This should have a dx right here. So we'll now have, let's call this integral I1 for now. So I1 is going to be equal to sine x ln cosine of x from 0 to pi over 2 minus the integral from 0 to pi over 2 of v du, well, that's sine x times negative tangent of x, so that's positive sine squared x over cosine of x. So let's evaluate this right here. So we'll have the limit what's going to happen at pi over 2? We'll have a similar case to before. We just cannot do anything with it. We'll have the limit as x approaches pi over 2, sine x, ln of cosine x, and at 0, well, that'll just become 0. Since we have ln of 1, that's 0. Now for this integral, we have sine squared x. Well, sine squared x is the same as 1 minus cosine squared x. So we'll have 1 minus cosine squared x over cosine of x dx. And this stays the same, plus. So now we can rewrite this as secant x minus cosine of x dx. So what is this? Well, the integral of secant x, this is one which is really known. So we have secant x plus tangent x from 0 to pi over 2. And we just evaluated negative cosine of x before, right? From 0 to pi over 2, that doesn't become negative 1. So now let's look at this. As we go to pi over 2, right, this is not going to be very useful. This will again become a form in which we can't evaluate it. So we'll have the limit as x approaches pi over 2, sine x ln cosine of x, plus, notice that we can take out the 1 over cosine of x. So I'm going to rewrite this, right, as ln absolute value of 1 over cosine of x plus ln 1 plus sine x, right, ln of 1, right, yes, 1 plus sine x, right, and I'll evaluate this from 0 to pi over 2 minus 1. Okay, so with this limit here is going to stay the same. What happens at pi over 2? Well, we'll have 1, ln of 1 plus sine, so we sine of x, that gives us ln of 2 right here. Ln of 1 over cosine x, well, that's ln of 1 over 0. That doesn't really make sense. So we'll have to just take the limits as x approaches pi over 2, right? Ln of 1 over cosine of x, that's the same as negative, right? Ln of absolute value of secant of x plus ln 2. And now what's going to happen at 0? Well, ln of 1 will become 0. This also will become 0. So we get 0 for that, minus 1. Okay, so now we have a few things we can work with. Also, this should not be cosine of x. This shouldn't be a cosine x, not a secant x. So here we have this. Now let's go back and let's see what we had. We had I1 right here, and then we had this right here. So let's plug this in. So we have negative, the limit as x approaches pi over 2, cosine of x, ln cosine of x, right, plus the limit as x approaches pi over 2, sine x, ln cosine of x, minus the limit as x approaches pi over 2 of ln of absolute value of cosine x. And notice we had a minus 1 here, so we have plus ln 2 minus 2. Okay, now let's see, what can we get with this? So as x approaches pi over 2, so let's look right here first. As x approaches pi over 2, sine x approaches 1. And since we know, we can really just multiply this out, and we'll get plus the limit as x approaches pi over 2 of ln of cosine of x. And here we have minus the limit as x approaches pi over 2 ln of absolute value of cosine of x. So how can we make sure that this stays positive? Well, notice, is this going to be a rough sketch here? At pi over 2, cosine is positive whether we're on this side or we approach it from this side right here, or if we're really close here. So we can really say that cosine is anyway going to positive. So we can really we'll just remove the absolute value, and we just leave cosine of x. So both these limits will cancel out. Plus ln 2 minus 2 stays, and we have negative the limits as x approaches pi over 2 cosine of x ln cosine of x. So what happens as we go to pi over 2? So this we can do, let me Just put this here. Now we'll say, well, let's see. Let's write this like this so we can apply a L'Hopital's rule. Cosine of x, well, ln cosine x, that's order infinity. So let's write this as ln cosine of x over secant x. Secant x, that's going to go to infinity. And ln of cosine x is also going to infinity. This means we can apply L'Hopital. So what is this going to become? Well, we have ln 2 minus 2 minus the derivative of ln of cosine x. Well, that's cosine x, negative side, that's negative sine of x, over cosine x, that becomes positive. The limit as x approaches pi over 2 of tangent of x. Well, what's the derivative of secant x? That's secant x. Tangent of x. Tangent x cancels out, tangent x cancels out. We get ln of 2 minus 2. The limit as x approaches pi over 2 of 1 over secant x. Well, 1 over secant x is the same as cosine x. So this is the limit as x approaches pi over 2 of cosine of x. So this is just 0. So we have ln 2 minus 2. And that is the value of our integral now.